Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge and the problem is Toeplitz Matrix. Given a m cross n matrix, return true if the matrix is a Toeplitz, otherwise return false. What does the matrix? How does the matrix is called as a Toeplitz? A matrix is Toeplitz if every diagonal from top left to bottom right has the same elements. That is, you can see that this 1 1 1 is having same elements, this 2 2 2 having same elements, and 3 3 3 having same elements, and 4 4 4 having same elements. That is, every elements in the particular diagonal is having a same elements, even this 5 5 and even this 9 9. If you consider this diagonal, there is only 9, and this diagonal it is 5, and this diagonal there is only 1, and this diagonal there is only 2, and this diagonal there is only 3, and this diagonal there is only 4. So obviously every diagonal has a unique element in the sense only one element which is equal to every element in that path in that diagonal. So we call this matrix to be a Toeplitz. So how can we solve this problem? In this second example, if you consider this diagonal, there is a 2, no problem. But if you consider this diagonal, there is a 1 2 and there is a two elements, that is 1 and 2. There are two different elements, so we are returning a false. So what we can do here is we can just have a map so that we can say that is a unique elements, or else we can have we instead of having a map, what we can do is on the go. We actually, what will be the brute forces? We can go for every diagonals, and we can store that every diagonals in a map, and then we can see whether the map size is 1. If the map sizes or the size of the set is 1, then we can continue further, else we have to return false because there are two different elements in that particular diagonal. So but how can we do that better? How can we optimize the space? Yes, we can optimize the space because while going through the diagonals, as you can see that the this element 1 is equal to the next element 1, and this element 1 is equal to the next element 1. But in this example, when you see this element as 1 and you see the next consecutive element in that particular diagonal is 2, there is a conflict. There is the different elements in that particular path. So obviously you can return false. So that is how we are going to do. Since there is only one element, we don't want to necessarily use a map or a set to store the elements. Instead of using an extra space, we can go through all the diagonals and just see the consecutiveness. That is, when there is a break in consecutiveness, we can obviously return false. So that is what we are going to code here. That is a simple approach. But how can we go for all the diagonals? Consider we are to go for all the diagonals, we can start from this. We have to do a diagonal path for each and every starting row and each and every starting column. That if we do like that way, if we can reach for every diagonals. That is, from starting here there is only one element which is in this diagonal. From starting this point, there is only one there is a diagonal with two elements in this path, and from starting this point there is three elements starting in this diagonal, and from here there is three elements, and from here there is a two elements, and from here there is a one element. So what I come to say is, from every starting elements of this row and for every starting elements from this column, if we start a diagonal path using some while loop or some loop, we can go each and every diagonal in the whole matrix. So that way we can pass through the diagonal. So that what will be the time complexity for this approach? The time complexity will be order of n square, or you can say it as n cross m, where n will be the number of rows and m will be the number of columns, and the space complexity will be order of 1. So we are not using any extra space, we will be just traversing this matrix itself. This way we can reduce the space as well. So how can we do this? Let us first try to take the size of the matrix. Matrix dot size, and this is the row and this is the column. Matrix of 0 dot size. We have the rows and columns n cross m. Now what we have to do is, first we have to go for each and every row. So we can first start from I int I equal to 0, I less than, or else to be more readable, row equal to 0, row less than n, and row plus plus. So this is my starting val, int start value. Start value is equal to nothing but matrix of row, this 0th index, 0th column. So this will take the all the values of this first column, all the values of this first column in each row, 1 5 9. So now I have the start value. Now I should go for every diagonal. How can I go in that particular diagonal? If this is my point, that is 0 comma 0, to go for this diagonal element, it is nothing but 1 comma 1. That is, I want to increment both I and j, that is both I and j. So if I am here at this position 0 comma 1, sorry, 1 comma 0, its diagonal element is nothing but 2 comma 1, which is nothing but 1 comma 0, 1 plus 1, which is 2, 0 plus 1, which is 1. So 2 comma 1. So what I can do is I can have two variables, that is nothing but my indices. I will say it as, how can I say, the diagonal row. Diagonal row equal to start from row, and my diagonal column. Diagonal column start from 0. Starts from 0. Okay, now what I can do is I can run a while loop while my d row is lesser than my row, and my d column is lesser than my column. What I can go do is I can just go in a diagonal path, going in diagonal path. So what I can do is, if it is my d row and d column is less than rows and columns, then I want to check the value and that particular matrix. Int val is nothing but matrix of d row and d column. If my current val, I can say it as current val, if my current val is different from my start value, if my start value is not equal to current val, then I can just return false, because there are two different elements. If it is not so, then this is same as that start value, so I can just increment both my d row plus plus and d column plus plus. So at the end of the day, if I can go for all the diagonals and see that where there is only say one element, then I can say return as true. But this is not the case. This is not the only case. I am going for each and every row for the 0th column. Now I have to go for each and every element in my 0th row. That is each and every element in 0th column of every row. This may take care of this case, and now I have to go for each and every element in 0th row of every column. So now I have to take care of this case. So what I can do is I can just run a for loop from for int call starting from 1, I can say, because I can go for 0 1 2 3, but I have taken care of this 0th row in this for loop itself. So I can go from call equal to 1, call less than my m, and then call plus plus. Now my start value, int start value is equal to matrix of 0th row and the column value. Now my int d row and d column is nothing but so my current d diagonal row is nothing but my 0, and int diagonal column is nothing but my current column, and I can just have this similar for loop. That's it. If this is not equal, then I can just return false, or if it is true, we can just go forward. So that's it. We can just run a loop, run the code now. Superb, it gets accepted for example 1, and let us try to run the code for the example 2. It gets accepted. Let us submit the code. Superb, it gets accepted, and hope you like this solution and let me know in the comments. But now what I can do is I will try to modeler the code. What does that mean? Because you can see that this code is the same as this code. It is similar, so we can just have a function instead of doing this. What I can say is, if check diagonal path, if this check diagonal path is going to return me a false, if it is going to return me a false, I can just return a false, because I'm going to say that this sectional diagonal path is going to return true or false. If it is going to return me false, I will take the not of that case and it will enter this if condition and return me a false. So I can have this check if condition, and now what I can do is I can write that, I can define that check diagonal path that is going to return me a bool check diagonal path, where I'm going to pass the parameters. I will check and pass the parameters. Wait a minute. So this is going to return me true finally. So what I can do is, now I have to pass the matrix, the vector of int. Now I have the two-dimensional matrix, and then what I have to have is d row as well as the d column. What are the other parameters? Int row and int column. So I have all the parameters now. So what I have to pass is matrix, then d row, which is nothing but my row, then the d column, that is 0, and then the row and column. So I can have just passed it. So similarly what I have to do here is I have to add this case here as well. So if I had this condition, now I want to pass here 0 and I have to pass the column. I can just eliminate these two conditions. So even I have to have a start value. So what I have to do is I have to pass the start value, but I can just take the start value here. Int start value is equal to matrix of d row and d column, if it is easy here. Instead of declaring here, we can just eliminate this condition here. So as you can see that it is much readable and it is very easy, very simple, very smaller than the before code, right? I have this function for each and every starting element of that row and each and every starting element of that column. I'm just going in its diagonal path and checking whether it is valid or not. If it is not valid, I'm just returning a false. So now let us try to run the code. Superb, it gets accepted as you can see, and let us try to submit the code as well. Great, it got accepted. So hope you like the solution. Let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.